4.2, officially it's graphing rational functions. Now, if you're looking at your notes, there's no graphs till we get to the back side, right? So on the front side, we're going to be working with some of the pieces of rational functions and just how to find them, okay? Specifically, one of the big things we're talking about today is asymptotes. So again, I thought you knew asymptotes. You're going to know by the end of this lesson, okay? So a few definitions here. First of all, if we go back to, I don't know, when did you first start talking about the word rational in math? At least middle school. I don't know if rational numbers go back to probably middle school. Because a rational number is any number that can be expressed as a fractions. Okay. Up here you'll see it says a rational number is a number that can be expressed. It says as the ratio of two integers. But what's the ratio? A number compared to a number. So in other words, a fraction. Okay. Now, so 1/2 is a rational number. 3/4 is a rational number. I'm going to say 0.75 is a rational number because I can make 0.75 into a fraction. Okay. Now, we're working with rational expressions. An expression that can be expressed as the ratio of two polynomials. So basically, we're working with equations where there's stuff on top and bottom of the fraction. A rational function, any function defined by a rational expression, pretty much the same idea. They just, talking about specifically being a function. Okay, guys, 3 key rules here. These are rules that you're going to want to refer back to often in your notes. Okay. Vertical asymptotes. First of all, let's start with the basics. Which way is vertical? Up and down, yes? Do we know that? I don't know. There was a point in my life that I got it confused, so don't know where you guys are at. But a vertical asymptote is always of the form x equals a number. Okay? So it's always going to be that line, x equals a number. And we find vertical asymptotes by taking the denominator and setting it equal to 0. So anytime you have a fraction, saying your denominator equal to 0, so any place that denominator will become 0, will produce a vertical asymptote. Okay? So that will be the rule we'll refer to there for vertical asymptotes. Then we have a rule for horizontal asymptotes. Now, horizontal are side to side. I always used to be told like the horizon. Like you can look out and see the horizon, it's horizontal. I don't know. Now, horizontal asymptotes, they're always y equals a number. Because a horizontal line cuts through the y-axis, so it's always y equals a number. There's a little different here. It's found by analyzing the biggest power on top and bottom of the fraction. And we'll go through examples, and I'll explain that. But you have 3 possibilities here. Okay? If the biggest power is on bottom, so if we start looking at powers of x, and the biggest power is on bottom, your horizontal asymptote is y equals 0. If the biggest power on top and bottom match, then you're going to have to look at the ratio of the coefficients, so what numbers are out front. And again, I'll show you examples. And then the third option is, if the biggest power is on bottom, there's no horizontal asymptotes. Okay, so we're going to work our way through those options. But those are the 3 options. It's all about, is x squared the biggest power on top, x cubed the biggest power on bottom, where is the bigger power? Okay, my examples in this next section will explain it. Okay, and then the third option we're going to talk about are what are called holes. Okay, so a vertical asymptote, horizontal asymptote produce a break in the graph. A hole is also a break in the graph. It's an x value. Okay, and it occurs if the functions on top and bottom can factor and reduce. The hole is the answer to the canceled piece. So we're going to do some factoring. We're going to do a lot of factoring in this chapter, but we're going to do some factoring today. And if you have a factor on top and bottom that cancels, like x plus 4 on top and x plus 4 on bottom, there's a hole there. Okay? So you're going to have these rules in front of you. I'm going to keep referring to them, okay? Let's go down. The easiest way to make sense of these rules, though, is to use them. So let's go down, look at A, and try and use the rule, okay? Now, the question here is what are the vertical and horizontal asymptotes of the graph of each function? So let's start with a vertical asymptote. Okay, what does the rule say up above about vertical asymptotes? How do we find them? We're going to set the denominator equal to 0 to find x equals some number, right? Now, my denominator right now, this is a common denominator for what we're doing here, x squared plus 7x plus 12. Oh, and actually I was going to write denominator equal to 0. So I'm going to set x squared plus 7x plus 12 equal to 0. Okay, guys, be smart. You know how to do this. How do we solve this equation? Yeah. I already warned you, we're going to do a lot of factoring, aren't we? Okay. This is easy factoring. You guys know how to do this. You've been doing this since Algebra 1. X squared breaks into, it's x times x, yes? And then we need two numbers. And those two numbers have to multiply to be 12. And at the same time, add to be 7. 3 and 4, 4 and 3. I don't care which way you say it. I don't care which way you write it. Positives or negatives? Positive. They're adding to be positive, multiplying to be positive. How do we officially solve? Set each factor equal to 0, yes? So x plus 3 equals 0. X plus 4 equals 0. Solve them, what do we get? Subtract 3, x equals negative 3. Subtract 4, x equals negative 4. Okay. Those are your vertical asymptotes. There would be basically breaks in the graph at those points. Okay, and as I said, we'll look at the graphs on the backside. Just trying to figure out how to use this information here. Now, it asked me to find vertical asymptotes and horizontal asymptotes. Okay. Horizontal asymptotes found by analyzing the biggest powers on top and on bottom. What's the biggest power on top? X to the first, yes. That biggest power term is 3x, so it's 3x to the first. I don't care about the rest, I just care about the highest power. What's my biggest power on bottom? X to the second, right? I don't care about the other terms. I just care about the highest power on top and the highest power on bottom. Now, the question becomes, where is the bigger power? In this particular problem, larger power is on bottom. Well, someone go back up and read the rule. What's the rule when the larger power is on bottom? What'd you say? Yeah. Right here, folks. Biggest power is on bottom. Y equals 0. So what's your answer? Y equals 0. You would need all three of these answers because there's two vertical asymptotes. X equals negative 3, x equals negative 4, and there's one horizontal asymptote, y equals 0. And there's going to only be one horizontal asymptote. Vertical asymptotes, there could be none, but there won't, or just totally confused myself. Vertical asymptotes, there could be 0, 1, 2, 3, 4, there's usually going to be at least one in what we're doing. Okay? Horizontal asymptotes, none or one are your options there. Okay? Okay, questions on this problem, because I'm done with this problem. We good? Huh?
Yeah.
Okay. And we're going to practice these others, so. Okay, let's try B. F of x equals 2x squared plus x minus 9 over x squared minus 2x minus 8. I'm going to start by finding my vertical asymptotes. How do we find vertical asymptotes, generally speaking? Yeah, the denominator equal to 0. Okay, so my denominator, x squared minus 2x minus 8 equals 0. What are you thinking here? Okay, 2 parentheses again. I told you guys we're doing a lot of factoring today. We're doing a lot of factoring in this chapter. Okay, so we're going to get our factoring review. X squared definitely breaks into x times x. Multiplying to be negative 8 and adding to be negative 2. So multiplying to be 8, I've heard the combo of 4 and 2, or 2 and 4, whichever way you said it. If it multiplies to be negative, one of these bad boys is negative. If it adds to be negative, the larger one is negative. So negative 4, positive 2. Now, common mistake is to stop here and say that my answers are negative 4 and 2. That's a common mistake. Don't make that mistake. What do we have to do? Okay, set them each equal to 0. And not that this last step is hard, but sometimes we just forget it. So if I set x minus 4 equal to 0, I'm going to get an answer of x equals 4. And if I set x plus 2 equals 0, I'm going to get an answer of x equals negative 2. Now, I don't know. I was worrying about 4.1 in Savas this morning. I didn't think to get 4.2. I'll try and do that later. But I'm going to tell you what I'm at. I hear people saying 4 and negative 2. Correct answers. However, make sure you put the x equals. These aren't just, it's not just the answer is 4 and the answer is negative 2. These are asymptotes. They are equations of lines. So you need the x equals if you want to get the full credit. Okay? Kind of like, do you guys remember when we did, we were graphing our parabolas and we did the axis of symmetry?
Yeah.
I was nitpicky. I said axis of symmetry had to be x equals a number, didn't I? Same thing. Okay. Okay, thoughts on horizontal asymptote? I heard Danielle say done. Okay, what do we notice about biggest powers? What's my biggest power on top? Biggest power on top is 2x squared. Once I identify that biggest power, folks, I don't really care about the rest. What's my biggest power on bottom? It's also x squared.
Oh, cancels.
Okay. So what do you notice about the powers? They are the same. Go back up top. If the biggest power on top and bottom match, is that the situation we're at?
Yep.
It's going to be y equals, and it says the ratio of the leading coefficients. Do you know what I mean there?
2 and 1.
There's a 2 here. What's the invisible number in front of x squared? 1. So it is 2 and 1. So let me write out here before I go. We had what I'm going to call matching powers. Okay. My matching powers then, we're looking at the 2 and the 1 out front. Okay. So yeah, you think about 2 over 1, but what do you know about 2 over 1?
It's just 2.
Just 2. So my horizontal asymptote is y equals 2. Okay? So there's another horizontal asymptote example. I said they're best if I just show you examples. Now you've seen an example. Jocelyn used the word cancel. Not exactly, but it does. You do think x squared's canceled. What's the numbers remaining out front? 2 over 1, which is 2. Are we good? Okay. I'm ready for C then. You guys ready for C?
Yeah, I guess.
As ready as it gets?
For everyone I get.
Now. Okay. Vertical asymptote, how are we doing those? Okay. That's at least the third time you've had to tell me that, so is it starting to stick in your brain? Now, then one of the options, and actually what we might do once we, is I tend to try and, factor everything before I get started, but
You have to take a GCF.
okay. There's two different ways we can do this in terms of solving. I'm going to talk about the factoring method. That's my preference because of other things going on here. So, in order to factor this, GCF of 3. They both divide by 3, yes?
Yeah.
So let's put this 3 out front. When you divide by 3, what do we get?
X squared minus 4.
Okay, x squared minus 4. Now, I'm going to encourage you to factor one more step. Yes, we could solve it at this point, but I have my reasons. I want to practice the factoring. The 3 is out front, yes?
Yeah.
Do you remember anything about x squared minus 4?
It's gonna be like, you have to use like the eyes.
No. You know this. I know you know this. Yeah, it's perfect square. So this is difference of squares.
It's gonna be like plus and minus 2.
Is this coming back to us? Square root of x squared? Or x squared? What's x squared always break into? X. Noticing this is a perfect square. What's the square root of 4? 2, yes? So what do we put in each parenthesis? A 2. How do you multiply to get negative 4?
Plus and minus.
You need a plus and a minus. The idea would be if I FOILed that out, that I would get x squared minus 4 back. Okay, because the plus 2x and the minus 2x would end up canceling. Okay, we've got to know how to factor that. Now, what's my step to finding my asymptotes?
That's it equals 0.
Okay, we're going to take them equal to 0. Now, the 3. It's a number.
Yep.
If I make the statement 3 equals 0,
None.
it's a false statement. Is there an x? No. When do I need to worry about setting that 3 equal to 0? When there's an x, when there's a variable. Then it matters. If it's just a constant, a number, no worries. Okay, so x plus 2 equals 0, and x minus 2 equals 0. If it's x plus 2, I don't even need to show the step, do I? What answers do we get? You get x equals negative 2, and you get x equals positive 2. Now, real quick, before we go down to horizontal asymptotes. This is a good example to look at. My other two haven't been ones that would factor. My numerators haven't factored. This numerator factors. And that's kind of an important thing to be aware of. So let's go, I'm just going to use right here. What do we already see that 3x squared minus 12 factors into? It factors into 3 and x plus 2 and an x minus 2, yes? I just took that from right there, yes? Now, the reason I'm doing this is I want us to see that numerator factored also. And again, I have my reasons, I'll get there. How's that numerator factor? X squared is x times x. What multiplies to be 4?
2. 3.
One.
Wait.
2 and 2 won't work here.
1.
4 and 1.
You don't know why it's a 3. That was a dog answer.
Now, before we go on to do horizontal asymptotes, do I have any matching factors on top and bottom
No.
that are the same? No? Okay. Then we're safe to go on to horizontal asymptotes. Okay. What do you see?
Those numbers.
What's the biggest power on top? X squared on top. What's the biggest power on bottom? 3x squared. What's the rule? Okay, matching powers, you're using the leading coefficients. What's my leading coefficient on top?
2 squared. 1.
Invisible 1, yes? So what are we looking at? We're going to be using 1 over 3.
Oh.
Okay?
Oh, yes.
Okay. Ready for D? How am I finding my vertical asymptotes?
Denominator D. Oh, 0. Oh my gosh.
Denominator equal to 0. X squared minus x minus 42 equals 0. We're getting the hang of this. X squared breaks into x and x. This is where knowing our factors is awesome. Multiplying to be negative 42 or multiplying to be 42 is some combo of
6 and 7.
6 and 7. If it multiplies to be negative, one of those is negative. Since it adds to be negative 1, negative 7, positive 6. Set each factor equal to 0. Okay, if x plus 6 equals 0, we're going to get x equals negative 6. Except if x minus 7 equals 0, we're going to get x equals 7. Now, I'm not in a good habit here, but what did I say I wanted to get in the habit of doing? Factor the numerator also. Okay, so let's go back and look at that real quick.
I have a question. Is that like, do you have to do that?
You have to on this one. The last one didn't matter.
Nope.
No, this one, it's going to matter. That's my hint.
We did it for fun.
Okay.
Bonus.
The last one we did it for fun. I was trying to like show you, okay, this is something we can do. It didn't really matter this time. This one,
What happens if you don't do it?
you're going to get an answer wrong.
Oh.
Okay. Okay, guys. X squared minus x minus 42. We already factored this into what? X plus 6, x minus 7. Okay, let's factor that numerator also. X squared breaks into x times x. What multiplies to be 54?
Positive 6 and negative 9.
Okay. Some combination of 9 times 6 is 54, yes?
Yeah.
I haven't gotten as far as my signs, but. If it multiplies to be negative, or adds to be negative 3, negative 9, positive 6. Okay. What do you notice here?
X plus 6 and x plus 6 are the same.
Okay. There's x plus 6 and x plus 6 on top and bottom.
They cancel.
Okay, they cancel. Now, if you go back, and this is going to be more important on the graph, so we'll get to on the back probably tomorrow, okay? But this is going to be more important on the graphs. But because these x plus 6 canceled, there's what is called a hole when x plus 6 equals 0. In other words, there is a hole at x equals negative 6. Okay? Now, you can have a hole or a vertical asymptote at a location. You can't have both. Okay, so there is a hole here, which means, what about these answers I just found?
Or not. That's a whole.
That one is not a vertical asymptote because it is a hole. Okay? It just means there's a blip in the graph, a missing spot in the graph. X equals 7. Is that still a good vertical asymptote?
Yeah.
It is. Okay? Now, so when does the factoring matter? When there's something that cancels. Because it's going to eliminate one of my vertical asymptotes. Are we understanding what I'm saying here?
Yeah.
Okay. The other part that I haven't done yet is
Horizon. Right. Horizontal.
horizontal asymptotes. Hey, I got it. That's how you remember it. I'll take it. Horizontal asymptotes. What do you notice here? Biggest power on top? Biggest power on bottom. So what do we notice?
It was A.
Powers match. What's my rule when the powers match? Leading coefficients.
1.
There's a leading coefficient of 1 on top, a leading coefficient of 1 on bottom.
Double. Oh.
What's 1 over 1?
0. Oh.
1 over 1 is 1. So you have a horizontal asymptote of y equals 1.
I give up on that. I'm answering.
Hey, you're with me. You're following along. I'll take it. You're allowed wrong answers. They happen. Okay.
Oh boy.
Now,
This way.
so we are going to look at graphs tomorrow. Okay? As we look at the graphs tomorrow, as you look at the back side, look with me real quick. It says to graph each function. Now, you remember what the functions looked like yesterday? How it's those two outward curves?
Yeah.
That's what they're basically still going to look like. They're the two outward curves. Okay? Now, on the back it says start by identifying asymptotes. Did we just practice our asymptote rules today?
Yep.
Okay? And then we're also going to need to identify intercepts. And we'll talk about that, about how we can find our x-intercepts and y-intercepts. Okay, so I kind of have 3 steps I take you through: asymptotes, intercepts, and then just maybe some other points if we need them to help these graphs. Okay, so we'll talk about that tomorrow. Your priority needs to be getting 4.1 done. Okay?
Because today is